Introduction to Terminating and Repeating Decimals. Every afternoon, as they were coming from school, the children used to go and play in the giant's garden. The giant was very kind to the children, teaching them many concepts they found difficult to understand. He was also teaching them concepts with new insight in his own new ways. This made the children smarter, and they loved learning from the giant. That summer, he was teaching the children about rational numbers. The giant asked the children to define rational numbers. One of the children said that they were numbers of the form p by q, where p and q are integers, and q is not equal to 0. Now, the giant had one more question for them. The question was, if you were given the decimal expansions of some real numbers, can you tell if the numbers are rational? Now, the children looked puzzled, and no one knew the answer. So the giant decided to teach the children about finding rational numbers by looking at the decimal expansions. At the end of this lesson, you will be able to explain terminating and repeating decimals. Terminating and repeating decimals.
Hi children, let's find the decimal expansion of 7 by 8. Dividing 7 by 8, since 7 is not divisible by 8, we place a decimal point, and place a 0 near 7. 70 is divisible by 8 times, thus, we get 8 in the quotient. And the remainder is 6. Proceed to divide in a similar manner. Thus by long division, we have the decimal expansion of 7 by 8, as 0.875. Considering the remainders obtained at each step, we have the remainders 6, 4 and 0. Since we have obtained the remainder as 0, we stop dividing further. Now, find the decimal expansion of 10 by 3. By long division, we have the decimal expansion of 10 by 3, as 0.333 and so on. At each step, we obtained the remainder 1. Thus, the remainders are 1, 1, 1 and so on. Here we could notice that the remainders are repeating. Let's find the decimal expansion of 1 by 7. By long division, we have the decimal expansion of 1 by 7, as 0.142857. Considering the remainders obtained at each step, we have the remainders as 3, 2, 6, 4, 5, 1 and so on. Here too, the remainders have started repeating. The number of entries in the repeating string of the remainders is less than the divisor. Thus, if the remainders repeat, then we get a repeating block of digits in the quotient. Thus for any rational of the form p by q, where q is not equal to 0, we have two cases. Case 1, the remainder becomes 0. In this case, the decimal expansion terminates, or ends after a finite number of steps. We call the decimal expansion of such numbers terminating. Case 2, the remainder never becomes 0. In this case, we have a repeating block of digits in the quotient. We say that this expansion is non-terminating recurring. A bar is placed above the digits, indicating that the block of digits is repeating. Thus, the decimal expansions of rational numbers have only two choices: either they are terminating or non-terminating recurring. We thus have every number with a terminating or non-terminating recurring decimal expansion. It can be expressed in the form p by q, where p and q are integers, and q is not equal to 0. Hope you could now identify if a number is a rational number by looking at its decimal expansion. We shall now solve few problems for a better understanding. Show that 3.142678 is a rational number. Solution. In the given number, we have 6 digits after the decimal place. Thus we could write 3.142678, as shown on the screen. We are thus able to write the given number in the form p by q, where p and q are integers, and q is not equal to 0. Hence, 3.142678 is a rational number. Show that 0.33 and so on equals 0.3 bar can be expressed in the form p by q, where p and q are integers, and q is not equal to 0. Solution: let the given number be x. One of the numbers is repeating, thus multiplying by 10 we get 10x equals 3.33 and so on. This number can be written as 3 plus 0.333, and so on. Now, substituting the value of 0.33 there and so on, as x we get 10 into x equals 3 plus x. Solving for x we get x equals 1 by 3, which is the required answer.
Conclusion.
Okay, children, I think it's time for you all to leave for your home. Hope this makes you clear about the terminating and repeating decimals. We studied that the decimal expansion of a rational number is either terminating or non-terminating recurring. Thus, a number whose decimal expansion is terminating or non-terminating recurring is rational.
Let's now summarize what we have learnt in this lesson. Rational numbers are the numbers of the form p by q, where p and q are integers, and q is not equal to 0. And the decimal expansions of rational numbers have only two choices: either they are terminating or non-terminating recurring.